All right, hello everybody. I want to say a couple things. Because of all the crap that is currently going on, I'm sorry, I can talk and do two things. All the crap that's sort of going on at the moment, I am sort of preloading these videos and lectures. So I'm working ahead of you. So just because something is showing up online, look to the syllabus and make sure that it's time to do those particular things. That's me just trying to get a lead on a changing situation at my end. The other thing, because I'm doing these back to back for the most part, my voice is starting to already turn into an issue and it's going, so I'll talk as long as I can and then have to take a break. But I just want to mention, because I know how cruel students are, when you see me wearing the same shirt in all these videos and you think I never change, or I think that this is so great looking, it's all being done on one day. So, cut me some slack here. And the hair is just, it's going to do what it's going to do. Otto is also with me, and there's construction going on next door. So we might just be interrupted by a dog that sounds like it's being beaten with chains. And it is just his freakishly high-pitched, scared sounding cry to warn me that there are people next door, as if I didn't know. So if that happens, we're just going to sit through it, and I'll just be embarrassed as a dog owner that this is my dog. The farting monster that he is also has a stupid, loud, annoying whine. So yay, yay. All right, so we are doing t-tests today. So make sure that you have with you the data sets for the lab. So 3 of them for the 3 different tests. Make sure you have your critical values table for the t-test. I'll show one at the very beginning of the video, but I expect that you're not going to want to go back and forth in the video to check these values. So make sure you have yours available. Make sure you have your calculator, writing utensil, because you are expected to be working through these with me. So you're getting practice, so you'll do better on homeworks and exams. Your second time through shouldn't be homework. Second time through should be the labs. Make sure you understand it, so your homework scores will be better, and then your exams will be better. And you need anything else? I think and the formula pages. Certainly it's going to be on screen, but have the formula pages with you for the t-test, and if necessary for the standard deviation, sum of squares. I assume you know the mean by now, but well, any other formulas that you require, all of that is necessary for today. All right, so let's go forward with the t-test. Now here's our a sample of the critical value table. So remember, just as our practice, this should be the table that I've uploaded for you. Make sure that you have the one that looks like this, but remember that when we're doing a t-test, we are always doing a two-tailed t-test. Our alpha level is always going to be at 0.05. So this is the column that we will be using. So even though there's a whole table, this is the column of interest to us. So make sure when you're using a table that you are looking values up in the right columns for them. Okay. Let's go ahead and get started. And I apologize that the window here, as always, is up in the upper right corner of the screen. I can't move it on yours. It's always, no matter where I have it on my screen, it shows up in the same place on yours. So it's going to include some of the words, but I think that that's not a big issue. Here is what a homework question, exam question would look like. So this is exactly what would have all the information required to sort of do this particular question. One last little bit of knowledge about this. I am not, unless I ask specifically, I don't expect you to do the null hypothesis. That's one of those things that is something you do in a stats class, but in reality, no one does it. So I need to make sure you can do it. I'm not going to knock you over the head with it. And so if I don't ask for the null hypothesis to be stated, don't worry about it. Okay, hopefully you understand what it is, but I'm not going to make you write it out like it looked like when we were doing the classroom video. However, every answer now, when we finish, must be in the final format, that extended format that we sort of saw with all answers from this point forward. And you're always going to be asked to interpret the question, make sense of the finding given the setup of the question, regardless of whether or not you're being asked specifically. So make sure that those 2 points, final format being correct and interpretation being correct, or at least being there, is here for all questions, again, going forward. Okay, so let's get started. Now, as I mentioned in the last video, we talked about the t-test for the classroom. It's extraordinarily easy to spot you know, what t-test to do in this particular situation. So I'm not even bothering to scramble these up because it's that simple. The one sample t-test is the only data set you're going to have where there's only one column of data. There's really nothing else where that's going to be the case. So this is what the data set would look like. There's only an X column, and that indicates that this is going to be a one sample t-test. Okay, remember, you have to make the right choices. What test am I using is also part of this. Remember, on the final, it can be anything. Now, correlation will say do a correlation. Regression will say do a regression. But the rest of them is just going to be a write-up like it is here. And you have to pick the right formula to use. So you're going to need to make sure you have that decision-making table that's in the like module Omega, I think is what I called it. That's very helpful in doing this. But this one is extraordinarily simple. One column of data must be the one sample t-test is going to be done. You read through this, you're working for probably the marketing department of a electric car factory. New model of car is going to be put on the market soon, or going to be marketed. And you're going to be presenting to the board. And your marketing materials apparently all look like you focused on safety and acceleration rates, which are things people look for in certain cars. And you find out, and again, you're really bad at your job if you didn't know this, but for this particular question's sake, you realize far too late that the feature that people who are going to buy the car are looking for is how long does the battery last, since you have to recharge these. So how far can you go with an electric car battery before it needs to be recharged? Okay, so this is why hybrids. And these are truly electric cars, not hybrid cars, which split the difference here. This would be a true electric car. Okay, so you've got this car, you've got to give this presentation to the board, you realize this fact is missing, and you've got to collect data. How does our car perform against the other electric cars that are on the market? So you grab 12 cars, these are at the factory. You get workers to go out and to drive as far as you can before you need to recharge and mark down the mileage, and then you're going to do a quick analysis for the next day, so you can include this in the presentation to the board. Notice in this that you are also given the average for the entire market. So this is the one that has mu in it, and that has to be provided for you. This is essentially what it's going to look like. It's not going to be like mu is. It will be in the terminology of the question itself, but it is here. It does say that the average for the entire market of cars is 125. So that we expect that to be the national norm, or that mu value that you require. Again, excuse me. I'm on video 3 today, so it's been a few hours of constant talking. Okay, so here is our data. People went out, drove, kept track of their mileage. Here's their mileage, and we have to determine how does this car fare with the rest of the population of electric cars. Now, of course, we'll get the mean, and that will be part of it. But just sort of thinking ahead, our hope is that our cars do better. It's possible. The second best option for us is that they are, the same as every other car, statistically the same as every other car. The worst option, of course, being that we're worse, statistically worse than the other car. So that's really the mind thought of the people who are conducting it. And that's the reason we're doing this analysis. Okay, let's see what we get. So first thing first, as always, start by writing the question down. Write the question down. Again, we're at the point where it's starting to change, but I still give a point for having the formula written. At some point, you don't get the extra point, but I remove a point if it's not there. So you still need to write these down, and that is to save a lot of problems along the way. So we write our formula down. This is the one sample t-test. Again, hopefully that was obvious to you. If not, go back and watch the other video, because that is a critical key to doing well on homeworks and exams going forward. Okay, so here's our formula. T is equal to the mean obtained, so our group mean, minus mu over S of X. So this tells us exactly what columns we're going to have. We know we're going to have to get the mean. So certainly know, if nothing else, we have to add this up, sum, and then divide by the number of scores to get the mean. This one has mu, and for this mu, it's a given value. We know that that's given. Here's 125 miles distance. And we have S sub X, which you remember is the standard error of the mean. To get there, we have to get the sum of squares, to get the standard deviation, to get to the standard error of the mean. So those are the steps we're going to, and to get for sum of squares, we are going to need the x squared column. So square each of those values, sum those values up, and then go through all of that. Now, the next slide is going to have a chunk of the work done. So for the next slide, I want you to create the other column, sum everything up, work your way all the way down to the standard error of the mean, then plug things into the t-test, but don't solve, and we'll check our work and then go forward. So pause here, and when you have gotten all the things that are necessary solved for what is here, then go ahead and start the video again. All right, so the first thing we have to do, again, the mean can be done at any time. That's straightforward. Mu is in the question, and S sub x, we're gonna have to start with the sum of squares, the standard deviation, to the standard error of the mean. So on this next slide, I've got some of that work done. So since I'm starting with the sum of squares to get to the standard deviation, to get the standard error of the mean, I have calculated my x squared column, and the totals here for these two columns are necessary moving forward. Sum of the x column, 1382. Sum of the x squared column, 161,638. Those are the values that are now put into the formula. Sum of squares is equal to the sum of the x squares minus sum of x squared over n, which means 161,638 minus the quantity 1382 squared divided by 12 gives us a sum of square of 2477.667. Take that, plug it into our standard deviation formula. Square root of 2477.667 divided by 12 minus 1 square root gives us a standard deviation of 15.008. Now, make sure you have those. If those are not the values you have, something has gone wrong, rework it, and then go back and make sure you have this. Then the next thing is the standard error of the mean, which again, I've asked originally for you to work all the way through that. So I'll just go ahead to the next slide right now. So our standard deviation carried forward is 15.008. The formula for a standard error of the mean is the standard deviation divided by the square root of n. So 15.008 divided by the square root of 12 gives us the standard error of the mean, 4.332. Now that's the thing that goes in the denominator of the question. So all of that work was done just to get to this particular number. I will say also in this, if I don't ask you to do confidence intervals, you do not need to do confidence intervals. I will either ask you to do those or not. This time, again, I think those sorts of formulas are easy enough at this point that you should be fine. But if not, you can solve for it. I'll give you an answer if you want it. But for this one, we just need to get the solution for t. Okay, so we take this. We would also still have to calculate the mean, which would be 1382 divided by 12. And pull mu down from the question and plug it into the t formula. And then, well, I've solved for t, but again, if you got to this point, you're not likely to make mistakes. That's why I'm really pushing you guys work on the beginning parts of the question, because mistakes don't really happen at this point. So our mean is 115.17. Subtract from that 125, which is the average electric car speed from the question, over the standard error of the mean, which is 4.332. We calculate that out for t, and that gives us a negative 2.270. Now, as I said before when we did this, it is possible to get these negative values. And in this case, this means that our value, when you have a negative value, our mean is below the mean we're comparing it to. So a negative t means that our mean score of 115 is lower than 125. That's how we got the negative value. When you're comparing this or using this in the critical value table, remember that we're using the comparison as the absolute value. So we really lop off the negative value and compare 2.270 to the degrees of freedom for this. All right, next steps. I want you to figure out the critical value. I always think it's a great idea to put the critical value down because it's easy for us to see it, because that mistake can be made without you realizing that you made it. It's not really a calculation. It's just you chose the wrong column. And sometimes we may look and look and look to find out where did my mistake happen. It's really not a math problem. It's that I wrote the wrong formula down. So I personally encourage writing the critical value down, but it's not something you get a point for. Unless it's something like confidence intervals where it is part of the formula. So I do need to know that you had that correct. Okay, so finish the question. So degrees of freedom needs to be figured out. Okay, got that in your formula page. Of course, you should also know what it is. We only have one group, so hint. Compare it to the critical value. Make your decision of whether or not it is significant. Write everything into the final format, and then go ahead and write up an interpretation for this. And we'll have all of that in the next page, and I'll walk through the answers for this to make sure that everybody has it. So pause here, go back, and let's compare our answers in just a bit. Okay, let's go forward. So the T critical value, so we had 11 degrees of freedom, so our critical value was 2.201. And our final format, T indicates the test, with 11 degrees of freedom, okay, that's n minus 1, is equal to our calculated value, negative 2.270. It is best form to put the actual value with the negative sign in if you have it. It doesn't change the interpretation. So, or I mean, it does change the interpretation. It doesn't change whether it is significant or not. So it's always best to include it because that does give us directional sign in terms of our interpretation. So I include the negative sign, and you should include the negative sign in the final answer. You just don't use it while you are comparing it to the response in the critical value table. Okay, to determine if something is significant, we compare our response, our obtained finding, 2.270. This is greater than 2.201. Okay, this is another one that squeaks by. So this is a significant finding. The negative sign means that it's on the negative side, which indicates our score is lower than the national average. And it is a significant difference because the absolute value of our calculation is greater than the T critical value. So this is a significant finding. That means the end of this is P is less than 0.05. That's what indicates statistical significance. Greater than 0.05 means that it is not significant. So T with 11 degrees of freedom is equal to negative 2.270. P is less than 0.05. Means we have a significant finding. And the other part is you can always look at the mean. See that our mean was below the other mean. We know that this is a significant analysis. That means our score ends up being significantly less than the rest of the market. So the interpretation of this is our new electric car. The miles, or the average miles between charges, is 115.17. This is significantly lower than the national average of cars. And that's certainly let the board know that, but that's not going to be a good meeting because this is a selling feature of this particular car. So that's what the final answer is supposed to look like with an interpretation. The reason I make you at least do that interpretation still is I think we turn interpretations into too much of a big deal. Like what could it's this simple. It's not, you know, great literature. It's like it is lower than, because I know that from the mean, and this is what I was doing, so it's in the terminology of what I was doing. So in this case, you're going to be telling the board that the new car that they have just created has a significantly lower charge distance for the electric car market, and it is significantly lower than the rest of the market, which means that this is a bad sign for selling the car, so they might want to invest in changing the battery. That's how the next step of the interpretation is. Then what would the solution be based on these results? You just need to write down the interpretation of the statistic itself. Okay. Ta-da! Hopefully that went well. If not, work back, check the figures, look to see where something went wrong. But if you got it right and you understand that interpretation and that would have been close to what you wrote down, you're in fine shape. Okay, next one. Problem number 2. All right, this one is about licorice, and everybody, by the way, licorice, other than candy corn and orange circus peanuts, the most disgusting candy substance on the planet. And I say that knowing that I grew up with really bad candy growing up, and we had like root beer candy and grandma candy as the good stuff. But licorice is awful. Those of you who eat it, but for those who like licorice. Apparently even they are a bit of snobs, because people who say they like licorice seem to like red licorice, and that black licorice is the worst tasting one. I judge both of you. I don't really care. So this is going to see, is there in a taste test on a scale, is there a difference between the taste of red versus black licorice? Is there a stated preference? So this would again be almost a marketing one. I'm going to give a series of people a taste test. As this is set up, a group of people eat black licorice and rate it, and people will then, or a different group of people will be eating red licorice and stating how what how they view the taste preference of that. On the scale, 10 is the best, so Snicker bar level goodness, and 1 is as awful as you can get, so punching a hobo, because I know that's the logical end of another scale. But is the question we're really asking, is there a preference for red versus black? Now, these are two independent groups, because once you eat any licorice, your entire taste palette is ruined for the next 70 hours, so you can't sort of do it within. Okay, the flavor would contaminate. And something like a flavor test is a really good example why you don't want to do something within, where you would have them test both of them in the same sitting to make that comparison, because the taste doesn't automatically go away. Like things like smell can be done, and other kinds of stimuli. Flavor lingers. So as a consequence, this would be best as a between subject, sort of project. So there are their scores. This is their rating on that 10-point scale, and there are the scores. So we're going to be doing a t-test because we have two groups. Two groups for us always are going to, unless we'll find out eventually, unless it's a non-parametric situation. Two groups, and it's not a correlation, of course. Two groups mean that we're doing a t-test. These are two independent groups, so we're doing the two sample mean or the independent mean for the t-test. So first thing is always write down the formula, and we go from there. So here's our formula for the two sample t-test. Tells us what we need to calculate. So we're going to need the means. So certainly we have to sum up each of the columns, x1 and x2, to get the mean. So divide by the total number there within each of the groups. We also need sum of squares 1 plus sum of squares 2. So sum of squares for the first group, sum of squares for the second group. Again, a reminder, you don't need to go to standard deviation or to standard error of the mean. All you need for this is to get the sum of squares. Okay, so when I say that sometimes exams take longer, and there are things that just eat away at time. You don't need to do those steps. You're never going to use those numbers, so don't do them. So that's why knowing what to do is important. If you were just like t-test, I'm starting with sum of squares and I just sort of go forward, you've done a lot of extra work. And when I'm thinking about what can be done within a window of time of like an exam, I'm not expecting those mistakes to have happened. I'm measuring how quickly doing it in the correct fashion would take a student. And I guess I always, whenever I can let students sort of behind the curtain to peek into academia, certainly for majors, this is sort of okay to know that. I'll let you know that in general, for all academics, a lot of things that look like they're accidentally happening in class are happening on purpose, okay? They are things to sort of prep for later. There are payoffs for some jokes later. Right now, I am in intro, and some people are upset. Well, it's intro. There's always a lot of people upset with intro. But one of the things that I'm doing is one of the big points of class that is coming up is when we hit abnormal psych, is I am trying to destigmatize and sort of show that a lot of the behaviors that people have with psychiatric issues is normal. I mean, they're normal behaviors. It's just those same behaviors to a degree. And so it's always moving. It used to be I would do this with depression or anxiety. Now it's kind of obsessive compulsive disorder. So I'm starting to talk about obsessive compulsive disorder in examples that I use for class. And what I'm doing is I'm sort of laying the groundwork. So later when I talk about it as a disorder, I can point out that all the way through, we've been talking about this as either good things about these traits or not negative things about these traits. And that's the kind of thing that's going on in class. Now, I have to work my way back to why I'm telling you this. And again, I've been taping for a long time, and I am forgetting. I have a complete brain fart about why I went on this particular tangent. Let's see, why am I telling you this? Shit, there actually was a reason. Oh, I'm sorry, I know what it is. For you guys to know, because I can't judge. So when you get, I already mentioned before that last homework is gonna be, there's a variation in time. I can't predict how long it's going to take. I wish I could say that the final homework will take 4 hours or it will take 30 hours. If that was the same time frame for everybody, or I give you a homework assignment and I know that it's due, 3 days later, am I giving you enough time to sort of do this? Or for an exam, however many questions I have on, how loaded should an exam be? How many questions should be on there? So at least for this one, I should let you know that these aren't sort of just, I throw questions up and just hope that you can finish. What I do is on these exams, I take them multiple times. Well, if it goes wrong, I take it multiple times. If I luck out, I only may have to take it once. But what my metric is on these things is, for exam in particular, where there's a hard 3-hour window, I take the test itself. And then because I know like the steps that are coming up, I don't have to look up formulas. I do write them down. I write every step down, just like I expect you to. And I do at least double check my work to do it. But however long it takes me, I multiply it by 3, since it's a 3-hour exam, to give an exam to you guys. So I have to be able to finish on exam day, an exam within an hour for me to give this to you. So these really are not capricious. If you're not able to finish in time, you actually are sort of slower than the average student. And there might be reasons for that, but extra steps is one of those places. You did a bunch of work that wasn't actually necessary. If you choose the wrong formula, you might be summing up columns that weren't necessary, double checking things that weren't necessary, and then doing formulas which were much more complex than the one you actually were supposed to do. So that's why I can't get it perfect for you guys, is that I can't judge what errors are going to be made along the way, or if you go off on a certain path, how it's going to happen. So I am trying my best to get these things done within the time frame. This has worked I've been doing it about 15 years now. This works relatively well. I haven't gotten like peak fast. I don't get any faster than I'm doing, so it still seems to work. But if you are finding that these things are taking too long, you do need to let me know. I will say also, as a professor, you got that lab time. So if you wait till Thursday night to start it and you run out of time, I have no sympathy for you. You had Tuesday that you could have been doing that work. Okay, so keep that in mind as well. Okay, so that was just, because I know that this one is going to start taking a little bit longer. I'm hopefully not overwhelming you, but if it is happening, let me know. Okay, and I may be able to do something with those things or not, but we'll certainly make a good faith effort to try that. Okay, so we know the counts we have, and by knowing you don't have to go beyond the sum of squares, you shouldn't waste time doing the extra work. All right, so go ahead and solve for this. So calculate the column totals, calculate the means, do the sum of squares for both group. N is also done. The other thing I'll mention, I guess I should do this because I noticed it in this one. Sometimes I'm going to have a little g down here. And so one way to do it is I can go with capital N or lowercase n, and to indicate whether it's the entire number of people or people within a group. I do try to give clues where I can. So sometimes if you see a little n with a g near it, and again, you can sort of see that PowerPoint doesn't always help me here, or equation model didn't help me all here. You can certainly tell that this is a sub G, and that is number per group. G stands for group, NG is number in group. The second one is sort of blew it up. It didn't do the subscript like it was supposed to. So just be aware that on the formula page, it looks a little bit different than this. G isn't an extra new thing that I forgot to talk about. It was supposed to be helpful and say that we're looking at the number of people per group, not the total number of people, which is sometimes done in some of these formulas. So NG, I try to stick that in to give you that indication as well. Okay, so get everything solved to be able to be plugged in. I'm pointing at my screen, you can't do that. Saying what I'm pointing at. Get everything to plug into the T and then come back and check. And fingers crossed I haven't solved the entire thing on the next page. I don't think I did though. Okay, so pause and then come back and we will check. All right, let's see how we did. And apparently we're going to take this in steps. Oh, and the formula is now covered up, but you know what it was, so that's okay. Mean of group 1, 1.889. Mean of group 2, 1.667. So I'm sorry, I guess I should also mention the column totals. Sum of x1 is 17. Sum of x2 is 15. Sum of x1 squared is 65. And sum of x2 squared is 31. So to get the mean, sum total divided by number within the group, gives us these means. Okay, then we solve sum of squares for group 1 and group 2. Sum of squares is equal to the sum of the x squares minus sum of the x quantity squared over n. And I put the 1s and 2s in here again to give a little bit more guidance. So we're doing, because I know sometimes I put things on screen and it looks perfectly organized to me. We're going up and down, and some people think I'm going across. So I put the 1s in there just in case someone is reading this the wrong way. You don't need to do that, although it is helpful to do that. So certainly not in the formula, but SS1, SS2 is actually a good thing to have written down there. But again, I can find my way through it. Okay, so for the sum of squares for 1, you should have 32.889. Sum of the sum of squares for x2, or for group 2, excuse me, group 2 is equal to 6.00. So hopefully those are the answers that you got. Again, you can't see it, but if I went through, and of course, I think it's 9, 1, 2, 3, 4, 5, 6, 7, 9, just double checking myself. You have that as well. So everything, those numbers should all then be plugged into the T formula. And the next step is for you guys to solve everything. So take these values now in the formula, just plug it in as it is supposed to be. You have group 1, mean of group 1, mean of group 2, the sums of squares, and the ends to fill in. Go ahead and solve for T, do degrees of freedom, okay, which is different than it was in the single sample t-test. Get the critical value, make the decision if it's significant or not. So what I'm saying is finish the damn question. Write it out in the final format, and then make your interpretive statement about the outcome. Okay, so do all of that and then come back. Okay, let's see how we did with this. So again, I hope this isn't, oops, sorry. Oh, I'm sorry. Solve, put in the right format, interpret. So we go one more slide before we get there. Okay, so here's what it should look like. T is equal to 1.889, mean of x1, minus 1.667, mean of group 2, all over the square root of 32.889 plus 6.00 divided by the quantity 9 times 9 minus 1. So solve bottom here, divide into this quantity, take the square root, divide the bottom into the quantity at the top. You should end up with a T value of 0.302. Our degrees of freedom would have been 16, so there are 18 total scores, but we take a degree of freedom out for group 1 and a degree of freedom out for group 2, and we would look that value up in the critical values table to get our value. And this one's sort of easy to tell because it's less than 0, so this one is going to be non-significant. I didn't write it down because I know that already is not significant. So I just want to make sure we had one in here where the we had a non-significant situation, so you would see how the format changes. So in this one, lowercase t with 16 degrees of freedom is equal to 0.320, comma, p is greater than 0.05, which indicates it is not significant. We cannot reject the null hypothesis as a consequence, and our interpretation of this is there is no significant difference in the ratings between the red licorice and the black licorice. Okay, they both taste the same to people in our taste test. All right, I hope that one went well. And then we have our last one coming up. So let's see how we do on this one. All right, problem number 3. So as you've already guessed, this is a dependent T or the correlated T group. So in this case, again, I apologize that the box is, sorry, I moved the wrong thing on my screen. The box is overlapping some of the question. You're an MAT student, so you're in the education program, and you are wondering if what you're doing in the classroom is helping. You're doing something different than the other teachers. So you have a group of students who are working on reading retention, and you test them before sort of your intervention. So you test how much they retain after a test of some kind on reading comprehension. In the middle, you introduce your variable. Everyone is getting the same training program, and your hope, of course, is that it's going to improve scores. And you're going to test them at the end after they've gone through this training program you've created to see what the effect is on the reading comprehension. So on this test, the number of facts you can get right is 15. I put that in there, but we're not using it the same way as we did with the first one. So this just tells you what the upper level of the scores are on this particular test. And you want to see if your training program is effective. So you're doing a pre and post test design. That means one group of people tested twice, before and after. That means we're doing the dependent t or the correlated groups t-test. So when you put that formula up, and it's not going forward. Lovely. Oh, there we go. I have no idea why that went a little blippy, but it did. Okay, so here's our formula for the t-test. The mean of d minus mu is over the square root of the sum of squares for d over n multiplied by n minus 1. You see in this one, the g isn't there. So it doesn't have to be there. Sometimes it's there, sometimes it's not, apparently. But whenever you see that, don't think it's a different concept. It's just referring you to the group or not. Okay, so we know we have to calculate D scores because different scores are necessary. So to get the mean, we at least have to sum up the first column. We have to get the difference column form. So we have to create the column for differences. We need to sum it up and take the mean of that column. We need to square that column and then sum those scores, because we're going to need that for the sum of squares for D column. And n here is, of course, the number of pairs of scores. These are not, again, individual people, so we don't have to take out the two sources of variance. We want that one source of variance there. So go ahead and create the D column. Go ahead and create the D squared column and sum up those last two columns. You don't need to sum up these columns. Again, now my cursor is missing. Crap. Okay. All right, there's my cursor. So you don't need to sum these up. That's more of that wasted time. You're not using these scores going forward. We're using the difference score going forward. So this is another place where you can waste time doing something that isn't necessary. Okay, so difference score, different square score, sum those two things up, and then we can plug things into our formula. The only other thing that's left over is mu. I will leave it for you for now to figure out what mu is. Okay, but come back and we'll have everything plugged into the T formula. All right, so I solved for the D column. And again, we get the positive and negative values and we treat those as adding and subtracting. We're not there, they are important for this. So when we sum the column up with the pluses and minuses, we get an actual score of 23, and we can take the mean from that, of course. And we get our D squared column, and we get a score of 163 for that. Now, solving for sum of squares, sum of the D squares minus sum of D squared over n, 163 minus 23 squared over 12 gives us a sum of squares for D of 118.917. So that goes down here, have the mean, mu, and n. Okay, some of those should be figured out for you. So I guess the next one's going to have everything on there. So if you haven't done so, also solve for T and interpret this. Remember, our question is, were students getting better or worse? Total number of scores possible were 15. What happens? Okay, so pause, solve, interpret, come back. Okay, so the mean of this was 1.917. Now, remember I said you needed to figure out mu, and I sort of at the beginning said 15 was the total number possible on the test, but I also reminded you that this is done differently than it is on the one sample test. Remember, on this one, mu is always going to be equal to 0 unless you are specifically told, and it would be said mu is equal to something. And by the way, I will never do that. So for us, it's always equal to 0. But that's the kind of thing that I can give you the formula on the formula page, and it doesn't get you 100%. You do have to remember some of these little details. Now, there aren't a lot of them, and really, this is the only wonky thing we've had up to this point. And until we get to the non-parametrics, it's the only wonky thing we're going to have. So the non-parametrics are where sort of the weird rules come in and extra things you have to remember. But that's why it's in section 4. It's an additional problem that you have to deal with, which is why we've been doing these sort of in stages of adding one new thing each time. So mu in this was equal to 0. So if you put 15 in there, just because there's a number in the problem that may look extraneous, it doesn't mean it's what you think it is. That was there just to let you know that these were raw scores, and you weren't, just for readers' comprehension, this class wasn't so bad that out of 100 points, they were all getting like 7. Okay, so the idea here is that there was a certain number of facts, and that was important to understand the setup. It wasn't important for the formula. So for us, in the correlated groups t-test, mu is always for you going to be equal to 0, but we still have to write it out because otherwise we've written the formula incorrectly. Okay. Okay, our critical value for this with 11 degrees of freedom, again, we're only taking out, there's only one group of people, so we're only taking out 1 in terms of degrees of freedom. Degrees of freedom are equal to 11. When we look the critical value up, that is equivalent to a critical value of 2.201. And our end result of our calculation was 2.02. Wait, did I make a mistake here? I may have actually made a mistake. Hold on. 2.02. Okay, I made a mistake. Wow. Yay, on video even. Woohoo. Woohoo. You can see. Oh, no, I'm sorry. I didn't make a mistake. I was just so prepared for, I haven't made one yet, so I've been waiting. I made a mistake on one of your homework questions. When I graded it, by the way, it was, I think, homework 1 or 2. Oh, it must be 1. I corrected it on my copy before I graded, so don't worry about that. But I've been dreading the day where I'm suddenly going to make a mistake on video and think, do I have to reshoot? Now, I'm not gonna. I'm just gonna tell you when I messed up. So I didn't make a mistake. This one is great. One of the things I've been doing is I've been choosing examples where it's been close to the critical value, and I was thinking of a different question. 2.201 is that I've used this critical value before for certain questions, and I know what that question is. So when I saw it, I flipped out. This is correct. I'm glad. So just pretend that didn't happen. Okay, so T with 11 degrees of freedom is equal to 2.02. Our obtained value is less than the critical value, so it is not significant. We cannot reject the null hypothesis. So P is greater than 0.05. Which means that this training program or this thing we created for the classroom in our interpretation was not effective. It did not lead to any significant change. Now, it led to a change. People, you can sort of see that the people who improved seem to, whether I guess the scores, I don't quite know how I set this question up, pre-test and post-test. Some people went down, some people went up, and if they went down, they really went down. And if they went up, they just went up a little bit. It's the negative signs are throwing things in terms of the interpretation. And the way that this test is done, it actually did harm for this. But because we're subtracting 0 from it, even though their scores went down, we're not going to see that negative sign in front because that's not how this works. And that's why, again, I can't give some hard and fast rules for everything because in some equations, the negative sign is treated one way, and other things it's treated another. So that's why we do the absolute value when we're making that comparison in the t-table. And that's really the main reason why we're doing it that way. So this is not significant. P is greater than 0.05. The thing that you're doing in the classroom had no noticeable effect, and truth, and you really can't say beyond that. You can't really then say, and it may have hurt them. Yeah, it may have, but that's like, she may be pregnant. That doesn't tell you if you are or you aren't, okay? These are statements of fact. So you wouldn't have to include that, that caution. That would be in the next phase. What am I going to do based on these results? The interpretation is just sort of restating the outcome in the terminology of the question setup and what they were trying to do. Anything beyond that is sort of the next step beyond interpretation, which isn't wrong, but if it's not significant, you really can't say anything. Anything you're sort of hedging about, you can't say because you don't know why it's not significant. You just know that it's not significant in this particular case. Okay, so that's t-test number 3. So that's all 3 of them. There is obviously a homework that is available for you, and it is due 9 o'clock outside my office for Sammy to pick up. on Friday. I hope the rest of your week goes fantastic. And then there's the awkward me standing at the door waiting to leave your home. All right.